A behemoth stirs the rise of active region 3364. The year is 2025. Humanity stands on the brink of a new era in solar observation with unprecedented technology at our fingertips. Our sun, a churning ball of plasma, awakens from its slumber. Its surface, a boiling cauldron of energy, begins to show signs of increased activity, hinting at the cosmic events to come. A colossal sunspot, active region 3364, emerges on the solar surface. This sunspot is not just any ordinary feature, it is a harbinger of significant solar events, a precursor to the sun's dramatic performance. 17 times larger than Earth, it dwarfs our planet. Imagine a spot so vast that it could engulf our world many times over, a true giant in the solar landscape. This sunspot, a dark blotch on the sun's fiery disk, signals a period of intense solar activity. It is a stark reminder of the sun's immense power and the dynamic processes at play, a testament to the forces that shape our solar system. A cosmic drama is about to unfold. The sun, our life-giving star, is preparing to put on a spectacular show, one that will captivate scientists and enthusiasts alike. Active region 3364 crackles with energy. The magnetic fields within this region are highly unstable, creating a volatile environment ripe for explosive events. Magnetic fields twist and turn, ready to snap. These magnetic lines of force are like tightly wound springs, storing enormous amounts of energy, waiting for the right moment to release. The stage is set for powerful solar flares and coronal mass ejections to erupt from this behemoth. These eruptions can release more energy than 1 billion hydrogen bombs, a true display of the sun's might. These events will have repercussions that reach far beyond the sun's surface, extending across the vast expanse of space, all the way to our own planet. The charged particles and radiation from these eruptions can affect satellite communications, power grids, and even pose risks to astronauts in space, reminding us of our delicate place in the cosmos. Cosmic fury, unleashed flares, CMEs, and geomagnetic tempests. These phenomena are some of the most powerful and awe-inspiring events in our solar system, showcasing the sun's incredible energy and influence. From the depths of active region 3364, a blinding flash erupts. This is the birthplace of a solar flare, where magnetic energy stored in the sun's atmosphere is suddenly released in a spectacular display. A solar flare, a sudden burst of intense energy, explodes into space. These flares can release as much energy as billions of hydrogen bombs, sending shockwaves through the solar system and affecting everything in their path. This is followed by a CME, a colossal eruption of charged particles, hurtling towards Earth at unimaginable speeds. CMEs can carry billions of tons of solar material, traveling at millions of miles per hour, and can have profound effects on our planet. Our planet braces for impact. The first sign of the impending solar storm is a surge of energy in Earth's magnetic field. This surge can cause a cascade of effects, impacting technology, communication systems, and even the health of astronauts in space. This triggers a geomagnetic storm, a disturbance in our planet's protective shield. These storms can last for hours or even days, depending on the intensity of the solar activity, and can lead to significant disruptions on Earth. The storm rages for hours, disrupting communication systems, causing power grid fluctuations, and painting the skies with dazzling auroras. These auroras, also known as the northern and southern lights, are a beautiful but stark reminder of the sun's power and its far-reaching effects on our planet. The sun's rhythmic heartbeat unraveling solar cycles. The sun is not a static object here. It is a dynamic, ever-changing star. It pulsates with a rhythmic cycle of activity, waxing and waning over approximately 11 years. This cycle is crucial for understanding solar behavior. These cycles, known as solar cycles, are characterized by the number of sunspots visible on the sun's surface. Sunspots are dark, cooler areas that indicate magnetic activity. We are currently in solar cycle 25, which began in 2019. This cycle marks a new chapter in our solar observations. Scientists predicted a relatively quiet cycle, but the sun has defied expectations. The sun's behavior remains a mystery. Solar cycle 25 is proving to be more active than anticipated, with active region 3364 serving as a stark reminder of the sun's unpredictable nature. This region has shown intense solar activity, challenging our understanding of solar dynamics. Echoes of the past. when the sun slumbered and Earth shivered. The sun's activity has varied dramatically throughout history, shaping the world in unexpected ways. There have been periods of prolonged solar minimums when sunspots were scarce, and the sun seemed to slumber, casting a chill over Earth. One such period, known as the Maunder Minimum, lasted from 1645 to 1715, plunging Europe into a deep freeze. During the Maunder Minimum, Earth experienced a period of unusually cold temperatures known as the Little Ice Age, where rivers froze and winters were harsh. Another significant period of reduced solar activity, the Dalton Minimum from 1790 to 1830, also coincided with lower global temperatures, affecting agriculture and livelihoods. These historical events underscore the sun's profound influence on Earth's climate, reminding us of the delicate balance between our star and our planet. Throughout history, there have been several instances of powerful solar storms that have left an indelible mark on human civilization. One such event, the Carrington event of 1859, is considered the most intense geomagnetic storm ever recorded. The Carrington event caused widespread telegraph system failures and sparked auroras so bright that they were visible even during the day. In more recent times, the 1989 Quebec blackout caused by a solar storm plunged millions into darkness. These events serve as stark reminders of the sun's potential to disrupt our technology-dependent world. Today, scientists closely monitor solar activity using advanced technology, aiming to predict and mitigate the impacts of future solar storms. With our increasing reliance on satellites, global communication networks, and power grids, understanding and preparing for solar storms is more crucial than ever. International collaboration in space weather research is key to safeguarding our technology and infrastructure from the sun's unpredictable fury. One of the most captivating manifestations of intense solar activity is the Aurora Borealis, or Northern Lights, and Aurora Australis, or Southern Lights. These mesmerizing celestial displays occur when charged particles from the sun collide with Earth's magnetic field and atmosphere. During periods of heightened solar activity, auroras become more frequent and intense, often extending their reach further towards the equator. The dancing lights of the aurora, painted across the night sky in shimmering hues of green, red, and purple, serve as a vivid reminder of our planet's dynamic connection to the sun and the boundless expanse of space that surrounds us. However, while variations in solar activity can influence Earth's temperature, they cannot explain the rapid warming observed in recent decades. This divergence is a critical clue in understanding our climate puzzle. The overwhelming scientific consensus is that human activities, primarily the emission of greenhouse gases from burning fossil fuels, are the dominant driver of global warming. This human fingerprint on climate change is unmistakable. While the sun plays a crucial role in Earth's climate, it is not the culprit behind the current climate crisis. Instead, our actions on Earth are tipping the balance, leading to unprecedented changes in our environment. While intense solar activity can pose risks to our technology, the sun also acts as a protective shield against other cosmic threats, safeguarding our planet in ways we often overlook. The sun's magnetic field, known as the heliosphere, extends far beyond the planets, creating a vast bubble that deflects harmful cosmic rays, acting as our solar system's first line of defense. Cosmic rays are high-energy particles that originate from outside our solar system, traveling at nearly the speed of light. These particles can penetrate deep into biological tissues, damaging DNA and posing significant health risks to astronauts and potentially affecting life on Earth. The sun's heliosphere acts as a cosmic force field, deflecting many of these harmful particles and protecting life on Earth, ensuring that our planet remains a safe haven amidst the vastness of space. As we move further into solar cycle 25, we can expect an increase in sunspots, more frequent and intense solar flares, and a surge in geomagnetic storms. These phenomena are not just random occurrences, they are part of a larger dynamic system that governs our solar environment. These events, while potentially disruptive, also offer invaluable opportunities for scientific discovery. Each solar storm provides a unique set of data that helps scientists unravel the complexities of our sun. Scientists are tirelessly working to deepen our understanding of the sun's behavior and its impact on Earth. They employ cutting-edge technology and innovative methods to analyze solar activity, aiming to predict future events with greater precision. By studying solar storms, we can develop more accurate forecasting models, which are crucial for preparing for and mitigating the effects of these powerful events. Enhanced forecasting models enable us to bolster our space weather preparedness and safeguard our technological infrastructure. This includes protecting satellites, power grids, and communication systems from the adverse effects of solar storms. And as we gaze up at the awe-inspiring auroras, we are not just witnessing a beautiful light show. These vibrant displays are direct results of solar activity interacting with Earth's magnetic field. We are reminded of the sun's immense power, its breathtaking beauty, and its enduring influence on our planet and our lives. The sun, in all its glory, continues to be a source of wonder and scientific intrigue, driving us to explore and understand more about our place in the universe.